Hello, I am Dr. Ritapa Bhattacharjee, Assistant Professor of Physics, Department of Basic Science and Humanities in SBIST. Today, we will be solving a problem which came in the year of MAKAUT 24-25 fourth semester. The question is, find the gradient of the scalar field at the point 1, -2, -1, and this is the scalar field. U x y z is equal to 4y square z x y square z plus 4x. So, how to find the gradient? So that you have given scalar field is U x y z is equal to x y square z plus 4x. Now, if we want to take the gradient of the scalar, what we have to do? We have to use the nabla operator and on this scalar field. So, it's just a scalar multiplication of with the scalar, a vector with the scalar. Like I am converting this u of x y z to a vector, so we are taking the gradient. So now how to write this? I have to expand this operator as del x I cap plus del y of j cap plus del z of k. This is the 3-dimensional Cartesian coordinate x, y, z, and this is if I have taken. So the expression of this operator is like this, and I have to multiply with u x y z. U x y z is a function of all these 3 coordinates. Now, if I am doing this multiplication, I will be taking the scalar product of this equation as so. Therefore, or del x u of x y z is what? I will take this given expression of the scalar field, that is x y square z plus 4x I cap plus del y of x y square z plus 4x j cap plus del z of x y square z plus 4x k cap. Now, or so I have to take the partial derivative of it. So if I am taking the partial derivative, means part by part. So if I am taking the derivative with respect to x, so I can take the derivative only with the terms which are having x. The other terms, because the derivative is not taken with respect to those terms y and z in this particular case, so it will not be derivable here. So what I will do here, this is the partial derivative. So with respect to x, I am taking only the x component of this quantity will get derived. Similarly, if I am taking the derivative with respect to y, only the term with y will be taken as derivative here. And then again, if I am taking the component of this part with respect to z, then only the terms with z, the z quantity related term, z term will get the derivative here. So, so here if I take derivative with respect to x of this term, so it will be equal to y square z plus here del x of 4x. So 4x is what? 4 is going outside as a constant, and del x of x equal to 1. And here also del x of x equal to 1. So that part I have written here. So this of I cap plus del y of this quantity. So del y of x y square z will be xz will remain as constant, and derivative of del y square with respect to y is twice y, and here because there is no term of y is present, so this part will not be derivable with respect to y, so this part will become equal to 0. So this is j cap plus here xz x y square will remain as a constant, so del z of z is 1, so this is 1, I am not writing here, and this term del z of 4x, there is no z term is present here, so this part will also become 0 is equal. So this is your k component. So if I am simplifying this, this will become y square z plus 4 I cap plus 2x y z j cap plus x y square k cap. So this is what? This is my gradient of u. Now what the question is saying? Question said I have to take the gradient of the scalar field u of x y z at the point 1 minus 2 minus 1, means value of x y z when x equal to 1, y equal to minus 2, z equal to minus 1, what will be the value of gradient of u? So therefore at the point 1 minus 2 minus 1, the gradient of u will be what I will write is, let us write this again, y square z plus 4 I cap plus 2xyz j cap plus x y square k cap. So I will be writing 1, means x equal to 1, here there is no x term, so this is equal to minus 2 whole thing square y equal to minus 2 and z equal to minus 1, so I will be writing here minus 1 plus 4 I cap plus 2 into x is equal to 1, y equal to minus 2 and z equal to 1 j cap plus x is equal to 1, y equals to minus 2 whole thing square because x y square k cap. So this will be equal to minus 2 whole square, so this will be equal to 4 and here again minus 1 is there, 4 into minus 1, so this will be equal to minus 4 and this is plus 4 I cap plus this is 2 into minus 2 and this is my, once again, x y z, z is equal to minus 1, so minus 1 into minus 2 is equal to plus, so minus minus it will be plus, so it will be equal to 4 j cap plus this is 4 k cap. So if I am writing in this way, so finally, so this will get cancelled, so 4 j cap plus x y square here, 4 k cap. So this is the answer of this gradient of the scalar field at the point 1 minus 2 minus 1. Thank you. 1 minute sir, এটা সুন্দর আছে।